Hi. So this is a prototype developed at Lightfish. It's an open source design. Very, very simple. So these are all 3D printed parts. Now we'll go to metal parts or acrylic parts. So it'll be much stronger and more robust. But this already works. It works well. There's enough pressure. You can adjust the speed. And also in parallel we're working on another system to prevent too much pressure going into the lungs.
Okay.
Just the speed here of the pump.
Okay.
And on this cam here there are four holes on the cam. You can't see it, but anyway, there are 4 holes there. And by adjusting the cam, you can adjust how much air goes out.
Okay.
Another idea that I have, which will be even easier, is just by replacing the pad here,
Okay.
making a larger pad, you will force more air into the patient. So by just changing this component here, you can change the volume of air that goes in and out. Yeah?
Okay.
So you have speed control, volume control, and pressure control.
Sure. So, I think this is the simplest design you made, right? Made in Lightfish, Auroville.
Yeah, so we've tried, I think, 3 or 4 different designs.
Yes. Successfully you came with
This one is very simple.
And this is a car, right now we are using a car windshield motor, right?
Yeah, windshield wiper. The nice thing also is we can have a good long backup on it. So this is taking about 10 watts of energy, so very less as far as energy consumption. We can connect it to a battery.
And according to when it's going for the price wise, what do you think? What will the cost wise? How much it will cost for going for when it's going for mass production or when the
It's a few thousand rupees.
Maybe it will be less than 7,000 to 8,000 rupees or less.
It depends on the components and availability of components. You can go for something cheaper, and then this mainly is being able to get the same component reliably.
Right now we are using a Toyota's Innova wiper company, which is
Every time you change one component, you have to take into many considerations to see that it still works.
okay.
So it's important to have at least some consistency in the components. We've tested with 2 different bags. So there's a bag which is slightly, there are actually 3 different bags.
One for adult and
one for adult and one for child. And then for the adult one, there are 2 different models, 2 different brands basically. But
okay.
it works fine for both. This component will have to have.
It's 3D printed, right?
It's 3D printed, yeah. So we can.
Can you say what's the use of this ball? Like.
So here, to make sure that if I block the air here, that it doesn't just keep forcing. That it's like
it's sending back to the.
Just sending it out.
Can you just show the demo? Like I can show for the audience. I can just show. You should block there. Okay. Okay. That's a very nice idea. Super. And here we are myself Prasanna here, and this is Samit in Auroville, and Samit has made this. Thank you.
A couple more things that we need to work on. Here we have a connector for oxygen. So
right now we don't have a cylinder, but we can able to connect with the.
Yeah, as soon as we get a cylinder, and we need to get a pressure control. So in that way we can have oxygen coming in. The other thing is to get actual digital or even analog readout on the RPM. So we need to know how many breaths per minute.
Yes.
So if we can have some sort of meter, that will be the next step.
So we are working on that, right?
Yeah, we're working on that.
We are working on the electronics part now. Sure.
One more step further, also from the research, is that there is a sort of a minimum amount of pressure that needs to be in the patient consistently, always.
Okay.
You need to have a minimum amount of pressure. So there we can have a second entry into this connector here, which will maintain constant pressure. And that will be either just a compressed cylinder, air cylinder, and that way it doesn't allow the alveola to collapse.
Okay.
Yeah. So oxygen, it will work with oxygen. And it should work with
RPM, digital micro controller.
That we need to put. No, right now I have a digital one which I can hold.
Okay.
And I can read it. But actually, if you have it mounted on the machine, then it will become more reliable.
Yes.
All right. So that's it.
Okay.
Happy to take it forward now. The machine is a pipe that goes here to the patient.
Okay.
So there's a flexible pipe. So he doesn't have to have this on his chest or anything. Of course, this can be put on the side.
Yeah.
And then
Because of the lockdown, we can't able to source all the components. So what are the components we had? So we are trying to source it from this.
Another aspect that we are trying to consider is to catch the air as it's being exhaled and filter it. So that's another component we have to look at, because you don't want to contaminate the environment. So we would have to have another connector here with a vacuum which draws that and puts it through a filter and then releases it back into the room. So that's going to take more time.
Okay. For initial stage,
that's not life threatening. That's just so slow improvements that we see happening in the future.
maybe version 2 or 3 we can
Version
do.
2 or 3.
Sure.
The basic model, the real basic model, which will allow someone in a case of emergency to get some air, will be just a few thousand rupees. Later on, it's really the components where that will play a big role in the cost, where we start having sensors and filters and electronics.
Yes.
So that will, of course, change.
Maybe.
But as far as like the basic mechanism, it's really simple. I don't think we can go much more basic than this. I think the components that we've used are components that can be found anywhere in India, and they're also components that are designed for really long life and long durability. So,
Sure.
yeah.
Nandri, thank you.